Okay. So problem 4.36. I'm going to use this using the universal method. I'm going to solve this using the universal method. So we want to find IA, IB, IC, and then for our second part, we reverse the polarity of the 140 volt source. So yeah, let me label each component or node. So I'm going to call this node and ground. Therefore, you have 80 here. First unknown node, second unknown, and then third, and then fourth. So we can, oh, I forgot. Make this I, D, I, E, or yeah, I'll do that. Yeah, that'll work. Okay, so let's do our KCL. So we know IA plus IC equals IB. And then we know IB is equal to ID plus IE. Right. So we know that V3 minus V4 equals 140. So that's another equation. So we have V1, V2, V3, V4, IA through E. Which is 5 variables. There, 1, A, B, C, D, E. Yeah. So there should be 9 equations, I believe. Yeah. So then, since V3 minus V4, right? Then we can say IA equals 80 minus V1 over 75. IB equals V1 minus V2 over 200. IC V3 minus V1 over 150. ID equals V2 over 125. And then we have IE equals to V2 minus V4 over 250. Yeah. And yeah, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, and we know ID and IE equal IA and IC. So that's, yeah. Go ahead and plug this into Maxima. So we have a equation CIA plus IC equals B. 3 minus V4 equals 140. Well, IE equals IC, so I can just replace that to, yeah, A equals 80 minus V1 over 75. B equals V1 minus V2 over 200. C equals 3 minus 1 over 150. ID equals IA, so I'm gonna replace that instead, V2 over 125. IE equals IC equals 2. V2 minus V4 over 250. What other equation am I missing? So yeah. Oops. Yeah, let's do that. 3, 4, 5, 8, it's gonna give us we can leave that 0. Should give us the same. Yeah, so we're gonna here, I'm gonna rewrite my EFC, my KCL, three equations I want to rewrite. So yeah, we're gonna erase this one since IE and ID are equal, and then so ID equals IA, and IE equals IC. 1, 2, 3, 4, 5, 6, 7. Oh, yeah. So if we were into we would have 7 unknown variables. That's my bad. IA, IC, right? So IA, B, IC. So we have 7, 7, right? So yeah, these are IA would be 1 over 10, IB would be 0.3, and IC would be 1 over 5, 0.20 amps, 0.1 amp, 0.3 amps. Yeah. So that's our result for that first part. I have it here. And now I'm gonna just draw over this. I'm gonna make this a negative and then this a positive. So our nodes would look a bit different now. Well, not, yeah. So say, oops, they wouldn't look a bit different. Some values would just change, such as, I mean, we know here, up here, the potential is negative. I mean, yeah. Anyways, let's get to the circuit analysis. Make this my ground node again. You have 80 here, V1, V2, V3, or I'm gonna do the same way I did it, the one above, that way, no confusion. And V4, okay. And yeah, we know that IA, just to see. Okay, so KCL, A plus IC equals IB. Equation for component. We have IA equals 80 minus V1 over 75. IC equals V3 minus V1 over 150. IB equals V1 minus V2 over 200. IA would be V2 over 125. IC would be V2 minus V4 over 250. And then for our last equation, V4 minus V3 be 140 instead of V3 minus V4 would be 140. So we have 7 unknowns, right? 1, 2, 3, 4, 5, 6, 7. Okay. So let's plug this into Maxima again. So equals V1 minus V2. V3 minus V1 V2 over 1.5. C equals 2 V3 over 250. V4 minus V3 equals 140. We have IA, IB, IC, V1, V2, V3, V4. Okay, so say this. So yeah, our IA, our current IA would change to 19 over 50, which is 0.38. So IA increases. You notice that IA goes up. IB is 1 over 50, whereas before it was 0.3, so IB goes down, and then IC, so IC instead is going in the reverse direction. So instead of it's actually going this way, it's 9 over 25. So IC actually increases this time. Yeah. So yeah, this is the answer for 4.36.